Hello viewers, welcome to the session on multi-arm bandit Thompson sampling in machine learning. Please make sure to watch all the three requested videos for your clear understanding and to make best use of it. We have already discussed about multi-arm bandit problem in one of our previous videos, and hence in this video we are going to focus only on Thompson sampling approach. So now let's look at the definition of Thompson sampling. It is a Bayesian approach to the multi-arm bandit problem, and it dynamically balances incorporating more information to produce more certain predicted probabilities of each level with the need to maximize current wins. Before moving into hands-on session, let's quickly have a look at the algorithm that we use in Thompson sampling. Here we have D arms. For example, arms are the ads that we display to the users each time they connect to a given web page. And each time a user connected to this web page, that makes a round. And at each round n, we choose one ad to display to the user. And at each round n, ad I gives the reward r of in, which can be 0 or 1. It gives 1 if the user clicked on the ad I and 0 if the user didn't. Our goal is to maximize the total reward we get over many rounds. And then ad I gets rewards y from the Bernoulli distribution. And then we are going to make use of Bayes rule formula, which is displayed right here in this slide. And then each round n, we are going to select that ad I that has the maximum theta I of n. And the basic three steps that we follow in each round is this. The very first step is at each round n, we consider two numbers for each ad I. So this selected ad I, we are going to compute two numbers, ni of 1 of n, which means the number of times the ad I got reward 1 up to the round n. And similarly, ni of 0 of n, that means the number of times the ad I got the reward 0 up to the round n. And then for each ad I, we take the random draw from the distribution using this formula. Theta I equal to beta of ni of 1 of n plus 1 to ni of 0 of n plus 1. And then we are going to select the ad that has the highest theta I of n value. So let us now understand it more clearly. For that, let's consider we are given 3 slot machines. Initially, we are unaware which slot machine is going to give the maximum jackpots. So the maximum expected probabilities of each machine is this. All of them are same. And we are unaware which machine is going to give the maximum jackpot at a particular stage. So we are given the same expected probability, which is nothing but the maximum distribution. And moreover, here we are not trying to guess the distribution behind the machine. Instead, we are interested only at finding out which machine is going to give the maximum jackpots, which depends randomly at a particular stage. So let us suppose after a certain level by level playing, we have obtained the graphs in curves in terms of this. These curves are obtained by the formula that we have already discussed in the algorithm, that is Bayesian approach and Thompson sampling formula. So let us suppose after a random click by the level, we have obtained our curve something like this. Then from this we can infer that with respect to the bandwidth and with respect to the accuracy, that machine 3 is going to give the maximum number of jackpots. Finally, it's time for your favorite hands-on session on Thompson sampling in Python. So I am inputting all the important libraries before proceeding, and we are going to use the same dataset that we have already used in bandit problem. That is the dataset of the ad agency. The ad agency which provided 10 different ads and its values randomly. See, 10 different ads. and 1 represent that the ad has been clicked by the user, and 0 represent that the ad was not selected by the user. So they have given us about around 10,000 records. Okay, we have to work and give a suggestion to the ad agency that which ad is trending right now and which ad can generate them a lot of revenue. So for that, what we have to, we are just following here the algorithm that we have discussed in the earlier slides. So initially I am importing the random model. Let me execute this chunk of code, because at the random any stage we can find out this. So initially the number of records here, n represents the 10,000 records, d represents the different number of ads that are 10, and ads selected initially we haven't selected any ads, so it is null empty list. After that, the number of rewards 1 means the ads 1 to a particular ad. Number of rewards is 0 initially. Similarly, number of rewards 0 is 0 for each and every ad, and then total reward is 0. These are the initialization of the variables. Let me just execute this fastly. See, it has been executed successfully. And now here comes the main chunk of code where we are using our Thompson sampling formula. For that, we need to understand these two loops, and then everything will be a cakewalk for us. See, just what we are doing. We are reading for each record. See, for n in range of 0 to n, means 0 to 10,000. For each and every record, we are doing this. Let me show you. Yeah, see, for each and every record, what I am doing, I have selected initially the ad is 0 and the maximum random value is set to be 0. And for I in the range of 0 to d, means we are selecting the different advertisements, ad 1, ad 2, 1 to 10, and then we are making for each of them we are calculate using the formula of Thompson sampling, that is random beta equal to random dot beta variant of number of rewards of I for that particular to 1. Initially it is 0, so if it has encountered 1, then it will be incremented to 1, and if it is 0, then again it will be incremented to 1. So this was the working of here, that is beta variant. And after that, if this random beta variant is greater than the maximum random value, then our maximum random will be random beta value. So ad is equal to, and that particular ad will be stored in ad, and it will be appended to the ad selected list, which was empty initially. And then if the reward is equal to 1, then the number of rewards will be incremented to 1, else the number of rewards of 0 will be incremented to 1. And finally, the total rewards will be the total rewards plus the reward. So I hope you are clear with the code. Let me execute this chunk of code. See, it has been executed successfully without any error. Now let's visualize the same graph using histogram, and now let's see the visualizations. See, it has been executed successfully, and you can see the indexing value is 0 to 9, means for 10 ads, and you can clearly see the top ad number 4, index value 4, which means ad 5 is trending right now. So we are going to suggest the ad agency as a data scientist that the ad 5 has a good trend right now in the market, so you should generate lot of revenue by displaying only ad 4, or else in terms of slot machines you can tell that the maximum number of jackpots which are possible presently is at a particular slot machine 5. And as usual, I have included code snippet for your fast revision, so you can pause your video right here and can take the screenshot of the same for your future reference. I hope this video proved fruitful to you, and hope you have gained something extra than what you were knowing earlier. Thank you.